going through these practice, you might want to have out the pink sheet with the parent function so you have something to refer back to, but not necessary. But again, it's helpful when you go through these. Okay, so for number 5, and again, not all the time are we going to ask for A, H, and K. It's just to get familiar with what we're looking for to describe these functions. So what is our A value? Assad. 1. Okay, Sawyer, what is our H value? -1. Good. Remember, it's the opposite of what you see. And our K, Blake. It's on the notes on page 4. Taylor. -2. So therefore, for this quadratic function, what is our new vertex? Emma. -1, -2. And before I start or move anywhere, how am I getting to -1, -2 from 0, 0? What do I have to do? Liam? Okay, what transformations are happening? Am I going up, down, left, right, reflected, stretch, or compression? No. Not for quadratics. Okay. Yeah. Left 1, down 2. Okay. The left is because of our -1. Down 2 is because of the -2. So again, if here is my parent function, and that's from the pink sheet, here's my quadratic, okay? And I am moving it left 1, down 2. That means all those points are moving as well. If you wanted to, you could put your new vertex in the middle of a table of values and choose 2 values to the left and choose 2 values to the right. But we only have to find the 2 values either to the left or to the right because you find all 4. Okay? This also follows a trend since our A value is 1. From the vertex, first perfect square is 1, and then I go over 1. Then back to the vertex after 1 is 4. 1, 2, 3, 4. Over 2. And then if I wanted to do up 9 over 3 to get my new function. But you could easily plug in values starting with your vertex in the middle. Okay? When you are graphing quadratics, so you might want to put this somewhere on your pink sheet, okay, where it says the quadratic function. If possible, you want to graph at least 5 points, okay, for your quadratic function, which was the second one we did. At least 5 points for a well-rounded graph. Some cases you might only get 3 depending on the coordinates, okay? 5 points, all right? Okay, now we're looking at number 6. What is my A value? Jackson. For 6? 1/2. Good. Nolan, what's my H? 3. Good. My K. Liam. Good. Okay. What is my new vertex? Sabrine. Good. 3, -5. So, what is one transformation happening? Danielle? Right 3. Louise, what's another? Down 5. And there's one more. There's one more happening. Cece, what's another one? You're right. It does have something to do with A. Anybody know? Yeah, Sawyer. Compression. Good. Vertical compression. Another word for compression that we use is shrink. So if you see that around, that means compression by 1/2. Okay. So same thing here. You could do, I'm going to show you 2 different ways, which I did in my other classes. You could start your table of values by putting 3, -5 in the middle, okay? Then choosing 2, 1, 4, 5, plugging it in. By plugging those x values in, it takes care of all your transformations, okay? Another way, which is another key way that you're going to need to know, if I was to give you a point and say transform this point all this way, you have to know what to do, what operations to do. So is it down 5? Down 5. Okay. So if I start with my parent function, okay, this is your parent function, okay, I can move the x values at any time, okay, I can move the x values at any time, which I'm going to start with first. So if I had to move, you guys told me right 3, what operation am I doing to x? Add, subtract, multiply. What's happening? Yep. Good. So if I am adding 3 to x, what's -2 plus 3? What do we have? -1 plus 3. 0 plus 3. Okay? So 1 through 5. Now, to find my new y values, what you have to do first, you have to multiply by 1/2 first. Okay? This has to be done first before you subtract or add to y. So for your y's, you're multiplying by 1/2. So 4 times 1/2, 2. What other x value do I know it's going to be 2? 5. Good. What is 1 times 1/2? 1/2, so I know that one. I also know that one. 0 times 1/2 is 0. Okay? So what I just did, added 3 to x, took care of my x transformation. Multiplied by 1/2 takes care of my compression. Okay? And last but not least, I'm just going to carry my x values over. Last but not least, I have to do what to y to show down? Danielle. Subtract 5 from y. So what's 2 minus 5? -3. If I know this one, what else do I know? Good. All right. 1/2 minus 5. And 0 minus 5. Okay. Which was our vertex as well. So this way, you might get a scenario saying, okay, 1, 1. I need you to transfer just that 1 point, vertical compression by 1/2, right 3 and down 5. You have to know what to do for that just 1 point. That's why I went through it step by step here. If you didn't write it down, okay. So these are actually your new points that you would be graphing. So we have 3, -5. Okay, and that's your new graph. Okay. Yeah, Genevieve. No, only the y. So thank you for bringing that up. The stretch or compression or reflection only affects the y. X values stay the same. Okay? So anything A related is y related. Okay? H is x related, K is y related. So since there's two things with y, you have to do multiplication first and then adding and subtracting. So I do want to actually mention one point. We're getting into our other functions. Okay? So for some of these, we're really not going to establish A, H, and K all the time, but it's for you to understand what each of these variables does. Okay? So for the cubic function, okay, this too, 3 to 5 points should be graphed. Okay? 3 to 5 points should be graphed. Cubic function looks very similar to a line. However, HK switches and makes a turn, which is called a point of inflection. Okay? Where it seems like it's kind of going constant and then changing. It's not. It's still increasing. It's just making a turn. Okay? So, for this first one, x minus 1 cubed plus 4. Keep in mind, all H, and K are all going to be the same thing. Do the same thing. So, what is my A value? Grace. Good. What is my H? Caitlin. Good. My K, Jack. 4. Okay. Now, the point of inflection where it kind of changes direction would be what, Danielle? 1, 4 is my point of inflection. Okay, it's your HK. So before I do anything, and I'll graph the parent function first, actually. And some of them might be off the graph, but okay. That's my parent function. Now, how do I go from a point of inflection at 0, 0 to now 1, 4? Lila, what's one direction I'm going in? Right 1. Louise, what's another? Up 4. Good. So here we go. Point of inflection. Okay. And then I know since there's not a stretch, 0. This one here. But say if I wanted one more point for -1, I could plug in -1. What's -1 minus 1? What's -2 cubed? -8 plus 4? So I know another point is at -1, -4. Since I can't see the other side. Okay. Right, so you could substitute x values in after the point of inflection, either above or below. Okay. Let's go through. All right, now number 2. Okay. We're going to do, actually, I want you to try number 2 on your own. Okay, give number 2 a try. So, we're going to just jump right into it. What's my point of inflection, Esteban? 4, -2. Okay, what is one transformation that happens? Addison. Right 4. What's another? Danielle. Down 2. Okay. Okay, and we know our A is 1, H is 4, K is -2. So 1, 2, 3, 4, down 2. And again, it's a rough sketch because we can't really see too much. So this is a prime example where 3 points would suffice. Okay. Now if we look at B, all right, what is my A value? Let's see, Genevieve, what's my A value for B? Good. Okay, what is my H value, Rosanna? 0. My K value, Assad, we're back to you. 0. What is my point of inflection, Sawyer? 0, 0. Okay, so 0, 0, we haven't really changed anything, right? 0, 0, we haven't moved left, right, up, or down. But what is actually happening here? What's one transformation? Braden. Okay, what does that -3 do to the graph, though? Okay, so we have a vertical stretch by 3. What else is happening? Sawyer? Okay, it's a reflection. It's a reflection. This one's going to look a little weird because when we say reflection, it's reflecting over the x, right? So if I started with a point 1, 1, right? If I plug in 1 cubed is 1 times -3. Instead of 1, 1 now, I'm 1, -3. Therefore, -1 is going to be where? 3. -1 cubed is -1 times -3 is +3. So the point of inflection is getting narrower. It's not, it doesn't look like the little constant piece a little bit. Okay. So I want you to try C on your own. There's a bunch of stuff going on in C. Okay. This one, since there's a lot, we'll go through A, H, and K. So Taylor, what's my A value? 2. Good. H, Emma. -1. Good. K, Nolan. 1. My point of inflection, Cece. -1, 1. Okay. So before we graph anything, what is one transformation? Grace. Good. Left 1. Good. Caitlin, what's another? Yep. It's okay. Vertical stretch by 2. Good. And Jack, what's another? Up 1. So we have -1, 1. Okay. Now, if you're not sure what points follow suit, an x value we could use is 0. What's 0 plus 1? 1 cubed times 2 plus 1. 3. So I know 0, 3. Now, I could also do -2. -2 plus 1, -1 cubed times 2 plus 1. Okay, and I could keep going to show, all right? This is what it would look like. Yes?
How is that point of inflection?
Well, I'm doing a rough sketch, but it's like that. It's right here. Is where it kind of changes direction, turns a little bit. Okay. Any questions on cubics? Yeah. No, negative just means reflection. Okay, great question. So anytime you are determining stretch or compression, okay, you always want to take the absolute value. The negative only means reflection. Okay, the next one is very easy. Okay, the absolute value function. Okay, it's very similar to a quadratic where you have your vertex of HK. However, two things. You should graph, again, 5 points is what we're looking for. Okay, but some cases it's off the graph, so you might only be able to do 3. Okay, so 3 to 5 points as long as you show the direction. One thing with absolute value, the A can be used for slope. Okay, the A can be used for slope. Only for absolute value. Okay, so we're going to jump right into absolute value without distinguishing A, H, and K. We might mention what the slope is, but looking at A right now, absolute value of x minus 3 plus 1. What is my vertex? Danielle? 3, 1, because it's still HK. What types of transformations happened from 0, 0 to now 3, 1? Addison? Right 3, up 1. Okay? Now, what is my A value here? What's my A? Brayden? 1. So I'm going to first graph my vertex, 3, 1. Now, since my A value is 1, my slope is actually 1 over 1. So from the vertex, I'm going to go to the right, up 1, to the right, 1. Whatever I do to the right, I also have to do to the left. So I continue like you would be graphing a line, however, going in the opposite direction. And that is your V shape. Yes?
So that slope essentially comes from that value of 1.
Yep, the A value. A value is 1, so that's your slope. Okay. In B, what is my vertex? Blake? Okay, if you don't see anything with the X, either add or subtract it to it, what should it be? 0, good. So your vertex is 0, negative 3. Okay, so 0, negative 3. Now, what transformations are happening here? Who could, let's see. Jackson, can you give me one? Down 3, good. Okay. Sabrine, can you give me another? There's 2 things actually happening. Negative means 1, and the 2 means another. Reflection, good. Reflection is the negative. Okay. Rosanna, what's the other? Good. And then a vertical stretch by 2. So this is a prime example where the A value has 2 things. The negative, reflection. But the 2 means a vertical stretch. That is also your slope. Okay. So from the vertex, since it's negative, negative 2, I'm down 2 to the right. I'm also going to do down 2 to the left to show my graph. Okay? Yes? Okay, and the last graph to get to is the square root. Okay? Parent function is square root of x. This one, probably 3 points to graph because you know the direction. Okay? Okay? So, HK in this case means your starting point. Okay? HK means your starting point. So, for A, what would be my starting point? Addison. 2, 1. Okay? So 2, 1. What was the transformation we just made? Lila, what's 1? Right, 2. Good. C. Louise, what's another? Up 1. Good. Okay. So this has come up before. How do we know what x values to use? Okay. Like, how do we know that? Well, we know this is my starting point. So I'm either going to go in the upward direction or the downward. I'm not graphing on this side. So that's my starting point. So it's all the x values to the right of that. Okay? So, Emma, what would be a good x value to use? 1's on this side, right? And this is our starting point. 3. So if I plug in 3, right? 3 minus 2 is what? 1. What's the square root of 1? 1 plus 1? 2. That's my next point. Now, what would be another x value? Yeah, Dina. If I did 4, okay? What's 4 minus 2? It's okay. 2, right? The square root of 2 gives you some sort of decimal, right? So our goal is to make this a perfect square. So what would be another value? 6. Excellent. So 6 minus 2, square root of 4, plus 1, 3. And I am glad that came up. Okay? I was going to mention it anyway. So the reason is your goal is to look for a perfect square, an x value that would make this a perfect square to find your y. Or else you're going to end up with decimals and it's going to be all messy. Okay? So I want you guys to try B and C. All right. So with B, Esteban, what's my starting point? 0, negative 3. So 0, negative 3 is here. Okay. Saying what type of transformations are happening? Perfect. Down 3 and a reflection. Okay. Perfect. Reflection because it's negative. Down because it's negative 3. So if you needed to, some people are getting stuck in terms of points, but this is your starting point. So just remember, you can't have negatives inside a square root. We'll make it imaginary. So it's going to be all the x values that are greater than this 0. Okay? So if we plugged in 1, what is our y value? Negative 4. Okay? How about 4? Negative 5. Good. Knowing it's going in that direction. Awesome. Okay. How many of you, in walking around, a lot of you did have this. So for B, how many of you did have that? Good. Okay. C, Brayden, what's my starting point? Okay, good. Negative 1, 0. Addison, what is one transformation happening? Left 1. Awesome. Okay. Genevieve, what's another? Good. Vertical stretch. Try 2. So here I could try 0. And what did I get if I plug in 0? 2. Good. Okay. Another one I could try would be, what would be next in line? 3. we get the square root of 4, which is 2. 2 times 2 is 4. So 3. Okay. How many of you did get that one as well? Good. Okay. So everything we have done, absolute value, quadratics, cubics, and square root, A, H, and K all have the same transformation, correct? H and K also means the same thing. Quadratics and absolute value have the vertex of HK. Cubics, inflection point is HK. Square root, starting point is HK. Okay, so HK is involved in everything. All right, so now we're going to try this next page, which is a warm-up. And if you want to work with someone next to you, you can. Okay, you're going to go through 1 through 3, describing the transformations, graphing these 3 functions, and then answering some questions below. Okay, try 1, 2, and 3 through the warm-up. Okay, so for number 1, okay, what is one transformation happening? Genevieve, what's one? A reflection. Let's see. Louise, what's another? Careful.
Oh, sorry, I was looking at left 2.
Careful.
Oh, down 2.
Down 2. Good job. It's okay. Taylor, what's another?
Left 3.
Left 3. Good. Liam, what's another? Is it a stretch or? It's a vertical compression. It's okay. By 1/2. Okay. If it's between 0 and 1, the absolute value of A, between 0 and 1, then it's a vertical compression. If it is greater than 1, absolute value of A is greater than 1, then it's a stretch. The negative just means reflection. Okay, good job. For A, Esteban, what's my vertex? 0, -3. Good. What transformation is happening? Lila? Down 3. Okay, so we have 0, -3. We have our points. Okay, and that is our graph. Okay, 0, -3, down 3. Good. For B, what is my vertex, Nolan? 1, 4. Okay, so 1, 4. Okay. What transformations happen? Blake, give me one. Right one, good. Emma, give me another. Up 4. And for this one, what is my slope? Addison. 1. And it's opening up. So we only see the 3 points there. Good. Okay, for C, what is my starting point? Jackson. Is -4, 0. Good. Okay. Side, what's one transformation? Reflective. Reflection. Okay. Caitlin, what's another? Left 4, good. 4, and then we have these guys here. Good. How many of you did have all 3 of those graphs correct? Okay. All right, good. All right. Then we have 3A. For what value of A does a reflection across the x-axis take place? Danielle. Negative. When A is less than 0, meaning it's a negative. Good. Okay, what coordinates of its vertex using H or K? What determines the vertex? Which letters? H and K. Good. So the vertex is HK. Awesome. According to this problem, which is a quadratic, what are the coordinates of the vertex? Caitlin. Good. 3/4 and 7/2. Excellent. Okay. So that warm up just then, even though it's in the middle of the lesson, end of the lesson, I should say, it takes everything you guys have learned in terms of transformations and highlights a few things and puts it on one page. So what you saw in that first blank, first spot, first number 1, you will have to describe transformations. You don't have to do anything, you just have to describe them. Then you have to graph, okay? Then you might be asked questions as, when is it negative? What is the vertex of a specific function? Whatever it is. Those are all types of questions you will see, okay? I might give you a point, which we'll see next class. -1,7, reflect it over the x, and move right 3. What do you do? Okay, those types of questions, yes.
Is it going to be this Friday or next Friday?
Next Friday. We're not done yet, okay? All right, so on your practice, I do have a helpful hint sheet that you can keep in your notebook. But if you turn to page 14, I believe, in your packet. Nope, sorry, page 11, maybe? Page 11, right? Okay, page 11 and 12. Okay, it's the 1.5 practice. Okay, you're going to work on numbers 1 through 3. And then on page 14 is the recap. Okay, so all of page 11, all of page 12, and then all of page 14, which is the recap. The one thing that we did not get into is transforming just random functions or writing an equation with a transformed graph. Okay, so that's going to take place on Wednesday. It's going to be pretty much half the class. Okay, to go through that, we'll do a little practice. Then most likely we're going to jump into piecewise functions, which is the last thing. Yes? Yes. Okay?